In this lesson, I will discuss how to write a test bench. So what is a test bench? Okay, so far we have learned different syntaxes, then procedural block, behavioral modeling, different type of modeling. So now in this lesson we will be learning how to verify our design, means how to check our design. Once you wrote your code for your logic, then it has to be tested. The functionality of the design has to be tested. It has to be verified whether whatever you designed, whatever you wrote, whether it is working properly or not. So that is to be checked and that is to be tested. Okay, so once the design is completed, what we do, we write the test bench to check. Okay, to check the functionality of your design. So test benches are used to check the functionality of your logic design, okay, or your logic. So what is the structure of test bench, or we can say the components of test bench? Okay, so the components of test bench, the first one is the module. Okay, then the module name. So this part is the module name. Okay, this part is your module name. This one is user defined. This one is system defined, or you can say library defined. This one is user defined. Then end module. Then inside that you can have data type declaration, you can have monitoring of inputs and outputs, instantiation of the design to be tested, then test pattern or the test vector generation. Okay, so I will discuss all these things: data type, then monitoring of input, then instantiation of design and test pattern, how to give test vectors, how to give the inputs to your test bench to verify the functionality of your design. I will explain in details by giving an example. Okay, then for monitoring inputs or outputs, what we do, we use this is dollar monitor break, this parenthesis, and dollar display parenthesis. And what are these things? This dollar, and this dollar monitor and this dollar display. These are system tasks. Okay, these are system tasks, and these are used for the test bench. Okay, for monitoring purposes. Okay, for monitoring your inputs and outputs. Then for test vector, what we do, we use initial blocks. So inside the initial blocks we give test vectors. Test vector means a set of inputs that is given to your design, and it is tested whether it is functionally it is working or not. So test vector means set of inputs, we can say. And this block is simulated only once at the starting time of simulation. That we know that whatever is written inside initial block, that is executed at 0 nanosecond, unless and until delay statement is there. Unless and until you have mentioned delay, then else all the things are evaluated at 0 nanosecond. Okay, so what is a monitor? What is dollar monitor? This parenthesis, it is a system task, and it is used to continuously monitor changes in the value of the elements in its sensitivity list starting from starting time equal to 0, and it monitors inputs and outputs variable they change. Okay, and you will get to know actually that what is the difference between this monitor and display. Just I am reading whatever is written here. Okay, and I have written, not written means I have written. Okay, and then dollar display it is a system task for displaying variables. It can be inputs and outputs at a selected time. Okay, another thing you need to remember, that inside your test bench you can have any number of display that you want. If you want 2 number, 3 number, 10 number, 20 number of display, you can write this task dollar display, then parenthesis this task. But normally monitor is written only once. Okay, that you have to remember. Okay, then sim time, then another word is sim time, and it represents simulation time, and it starts from 0. It starts from always 0. Then finish, dollar finish is it exit the simulation and gives control back to operating system, means it quit the simulator. I will explain it. I will explain all these things by giving you an example, that how this dollar monitor, dollar display, then same time, then finish, then stop, all these things are used. Okay, in writing test bench. So it is one of the example, hash 50, then dollar finish. So it is after 50 nanosecond, it will exit from the simulator. It means dollar stop, it suspends the simulator and put a simulator in an inactive mode. Actually, stop simulation. This is not interactive, actually it is a inactive mode. Okay, this one is inactive. Okay, so it stops simulation. So hash 50 dollar stop, after 50 nanosecond it will stop the simulation. See, dollar stop is it will stop the simulation. Okay, but you can resume that simulation. But what happens in dollar finish, it is exiting from the simulator, and that will be given to the operating system. Okay, and the control is given to operating system. That means if you want to resume that one again, suppose you want to resume that code again, you want to run that code again. So in everything you have to do, means what are the procedures that you have to follow, all the procedure you have to follow again from the starting once this dollar finish comes in your code. But what happens when dollar stop comes, it stops the simulation, but you can resume it. Okay, means the control is not given back to operating system, the control is on your hand. Okay, so that can be resumed again. Okay, whatever you are doing. Okay, you will understand all these things in details. Okay, then okay, let's design a logic for AND gate and writing test bench. Okay, the simple example I have given here. Okay, so this is a AND gate module, then name, then AB out. This is the module name. Input, these are the inputs, AB, output to output. So this is simple AND gate. Okay, this is a data flow model. Okay, and this is A, this is B, and this is my out. So see, this is AND, inputs are A, B, then output is out. So this is the block, this is my, it is also called sometimes DUT. Okay, design under testability or design under test, we can say. This is also called DUT, this part, this inside part means this one, this module, it is also called sometimes DUT. Okay, design under test. So inputs are A, so this, see, the signal A and B is input to this module, this block. Then what is the output from this block is out. Okay, so what happens when you are writing the test bench, so when you are writing a test bench, this test bench is a kind of wrapper. Okay, so it sits on the top of your module, your design entity or your logic design. Perhaps see, this part is your design is inside your test bench. See, this is your test bench, this is your test bench boundary. This one is, the bigger one is your test bench boundary, and the smaller one, this is your test bench boundary, and the smaller one, this part is your design. Here it is a AND gate. Okay, so we know very well that this input to this module is A and B, and output from this module is out. But if so, this is a, now it is a wrapper. So this is a top of this top module of this one. So if you draw a signal like this, okay, there is nothing outside here. There is nothing outside. Okay, you should remember that there is nothing outside. Whatever is there, whatever the signal is there, it will be inside only. It will be inside. So the signal is coming in this way, this signal is coming in this way, and this signal is going in this way. Okay, so it is coming from this module, from this boundary, so it is out, right? Now this A and B, so here A and B is output. For example, here the out is coming from this small module, the small block, right? So this is coming from this is coming from this small block. So this A and B, it is coming out of this big block, right? So these are now A and B. Now these A and B are output, right? Because it is coming from this one, and then this signal is entering into this block, this bigger module, this bigger block. So this part is the test bench. This part is your test bench, and this part is your design module. This is your AND module. So if this is your test bench, the wrapper means this top module, the top part is test bench. Then whatever is coming out, it is output. What is coming out? This A and B. And what is coming in? This out is coming in. See, this is out. This is going into this block. This is going into this block, and this A and B. This A and B coming from this outside part. Okay, sorry, coming from this outer box. So because of that one, what we do here, so this is the structure of your test bench. So this is module, then module name, here range A and B. Normally range is used for output, right? So this is a variable declaration, and see, this A and B, this A and B, it is representing output, right? This A and B are output, and this out is into this one, into this bigger part, this bigger rectangle shape, and this is out from this A and B is out from this one. As this is out, so it is a output. It is a output. But normally in test bench there is no output or there is no input we declare. So what if it is output? Then it is range, and if it is input, then it is where. If it is input to your big module, that big box. See here the big box, that is input to big box. So this out is now into this one. So this out is now in, means this out is in, means input. So input means, for input we write where, and for output this is range. Okay, so for the output here it is range. For this two it is range, and for this out we can say this out or this out. So this out it is where. So in test bench, inputs are where, and outputs are range. Okay, range type. So it is range is AB, where is out. Then initial and begin. Initial, that is for monitoring your waveform. Already I explained here. This is a system task which is continuously monitor changes in the value of the elements in sensitivity list. Means whatever is written inside this monitor, and there is changes. If there is any changes in A and B, then what happens? This part is evaluated all the time. So these are the sensitivity list. This A, this same time G, then this A, this same time, then this A, then this B, this output. These are the sensitivity list. So if there is any changes, in same time A and B, so what happens? We get the updated value. So it is monitoring. It is continuously monitors. It is continuously monitoring. It is like whenever there is changes in A and B, it is continuously monitoring, and it gives the output. Okay. So this is dollar monitor. This is the use of dollar monitor, and it is always written inside initial block. It is always written inside the initial block. Okay, it is it monitors inputs and output variables when they change, and it happens at time equal to 0. Okay, so this is what happens here, this monitor. Then this is module instantiation. Okay, so inside the test bench you have to see, inside the test bench, this is a test, the bigger module is the test bench, and inside what we have the smaller module, your design, your DUT, your design is there inside this module. So when you are writing the test bench, definitely you should include you should include the smaller part also. So here in the test bench we must have the smaller part. So this is a and diff. So what we have to give, this name we have to give. So see, what is the name of our module? This is and df. You should not change this one now. Okay, once your module name you should not change in test bench. So and df means here also it is and underscore df. This is user defined. This can be a1, a2, a3, whatever you want. Okay, so this module, this is module name, then your user defined name, then bracket, then next is bracket. Okay, then next is bracket we give, and then semicolon. Inside what we write, dot. Okay, this is called module instantiation. This is module instantiation. Okay, this A, inside the parenthesis A, inside parenthesis B, inside the parenthesis out. This A, B and out comes from here. Okay, whatever is written inside the parenthesis, this capital A, capital B and capital out has to be from this module, this one, A, B and out. And this outside part, this is dot A, dot B and dot out. This signal has to be from your design, this one, A, B and out. You should not change this one. You should have the same one, whatever you have mentioned here, whatever name you have given, capital A, B, out, whatever name you have given, that has to be inside the small part. Just you remember that when you are writing the test bench, and which one is visible to you in the test bench, the signals, that has to, these signals has to come here, okay, here and here, okay, and this A, this signal and this signal has to be from your module, from this module, from your module, okay. And always remember this, inside the test bench you have to instantiate your design, you have to instantiate your module, because this is the structure of test bench, okay. Then these are the test vector. Do you remember the test vector that in the test bench? See, already we declared that data type declaration. Inside the module there is data type declaration. So this is my data type, this is my declaration, right? Variable declaration, data type declaration. Then what next is monitoring of inputs and outputs. Monitoring of inputs and outputs. We have done here monitoring of inputs and outputs. So this is, we are monitoring here, right? Inputs and outputs. We are monitoring here. Then what is the third one? Third one is instantiation of the design to be tested. You should remember this part, this 4-1. What are the things to be inside the this test bench? What are the components? These are the components of test bench, okay. Then instantiation of the design to be tested. So what you are going to test, which module or which design you are going to test, and that one is this part. This is the instantiation of your design. What is the fourth one? The fourth one is your test pattern or test vector generation. That means you are giving a set of inputs. So we are giving a set of inputs, okay. These are test vector generation. So these are test vector, these are set of inputs, because here inputs are A and B. So at 5 initial, begin, end, after 5 nanosecond we are giving A equal to 0, B equal to 1. Then after 5 nanosecond A equal to 1, B equal to 1, then A. So these are the inputs, okay. This way it works. You should remember, you just remember these things. What are the components? What are the components for a test bench? Data type declaration, monitoring of inputs and outputs, then instantiation of your design to be tested, then test pattern or test vector, okay. Then this diagram, you should remember this diagram. Say which one has to be range and which one has to be output, and the range has to be always output of this one. So the output means it is coming from, this signal is coming and it is going into, this signal is coming from this border and it is going to this border, going into this border, okay, this small box. So the output from this test bench has to be range, and input to this module, this block, bigger block, has to be wire. That you have to remember, okay. So this is the components. All the components has been mentioned here, okay. And I explained this monitor part, what happens. So whenever there is changes, for example here I am changing A and B value, so it will be updated the same time. And you remember this same time, it represents the simulation time from 0. So first, see here, the first time will be, first time step will be 0, same time. So this is a predefined word, okay, predefined keyword we can say. So whenever you write same time equal to %g, then same time first it will be 0, nanosecond. Let's say it is nanosecond, 0 nanosecond. Next will be, so 0 nanosecond, A equal to, you gave A equal to 0, then you gave B equal to 1. Then what will be the output? Then what happens at 5 nanosecond? What happened at another 5, means 10 nanosecond, what happened? Then 15 nanosecond, what happened? Then at 20 nanosecond, what happened? So see here the signals are changing. At this point 5 nanosecond signal is changing, A and B value changed. Then 10 nanosecond it is changing, then 15 nanosecond it is changing, 20 nanosecond it is changing. So monitor means whenever there is a changes in A and B, it will be evaluated. This line will give you the updated output. This is what it is written. This is what it is written here. This monitor, it is used continuously, monitor, and it checks inputs and output variables, and if they change, then it updates the input and output variables. Okay, if there is a changes in sensitivity list, then it checks that one and it gives the updated value. Okay, this is how the monitor works. The next one is another example, the same example only here, but display, using the display task. Same range equal to AB, wire equal to out, then initial, begin, A equal to 0. So what it is written here, see the display, what it is written here, the display, it is a system task for displaying variables. Same, it is also displaying the same thing, input and output, but at a selected time. In monitor, what happens if there is a changes, if there is any changes, then the inputs and outputs are updated, and you can see that one on your monitor. But in display, what happens, at a selected time, we give the time here. For display, we give the time at particular time instance. If you want to see if you want to view the output, you want to monitor the output, then you can use the display. So it always associated with a selected time. A time is there. Okay. Here you can see the example. See, a equal to 0, b equal to 1. So this is inside the initial and begin. So at 0 nanosecond this happens, right? At 0 nanosecond this happened. But after 10 nanosecond, what it will display? A equal to b, means a will get this value, b will get this value, and what will be the output of this one? Here instantiation is there. So out equal to a and b. So you will get a value, b value, and out value. See, then this will happen at 10 nanosecond. Then after 10 nanosecond, what will happen? A will get 0 and b equal to 0. So now it changes. A and b value is changed. So these are test vector. Individually we have given the test vector. Okay. So after 10 nanosecond, means it is 10 nanosecond, this is 10 nanosecond. So this is 20 nanosecond. Total is 20 nanosecond. This is 30 nanosecond. So after 10 nanosecond, this one will be executed. After 20 nanosecond, this one will be executed. After 30 nanosecond, this one will be executed. Okay. But in this case, what happened? In this case, whenever there is any changes, so these are the test vector. If there is any changes in A and B, this one will be evaluated. Okay. This is the difference between monitor and display. Display is associated with the time, and monitor, it continuously monitors if there is any changes in the test this sensitivity list, whatever is written inside the monitor parenthesis, whenever there is changes in this sensitivity list, then it will be updated and it will give you the updated output. Okay, updated result we can say. So here it is one example. This is a 2:1 mux. So this is Verilog code for 2:1 mux. Then this is Testbench for that one. Okay, Testbench. So range is, see, in this case I0, this input is A, B and S, output is out. Okay, but in this case what happens? Range means out, right? It is associated with out. Okay, and where corresponds to input. So out here, whatever is input to, see, whatever was input for this one, that will be output for this one, Testbench. You remember, for example, you always remember, whatever is input for your DUT, your design, okay, DUT, that will be output for your Testbench. Okay, so now this I0, I1, IS, this is input for this one, this AB and is input for this one. Now it is output for Testbench. Out here, it is output signal, out, but here out is what? Out is where? So that means it is a input. Then initial, begin, the same sim time monitor. Then this is DUT instance. This is variable declaration. This is for monitoring purpose. This is your design instantiation, module instantiation. These are the test vector. Okay, these are the test vector. You can write this code, whatever I have written. You can write the same code on your simulator, and you can check, and you can implement this test. You can write this Testbench and you can verify what result you are getting. Okay, this is all about the Testbench, and I explained completely that what are the components, what is the structure of a Testbench, and what are there inside the Testbench, and how this variable are declared, range and where. Always remember, this is there is no input and output inside a Testbench. Okay, it is always range and where. Then how the module instantiation is done. Okay, this dot you should not forget. Okay, the dot, this dot, and this dot you should not forget. Okay, then I0, I1, S, and these are these signals. This inside the parenthesis, whatever is written, it comes from this Testbench directly. Okay, these signals. Okay, that you have to remember. Okay, so thank you so much for watching, and if you like the content, then please do like, comment and subscribe this channel. Okay, thank you.